Hello all, this is Dr. Alsop, and we are about to get into the wonderful world of joints, one of my all-time favorite things to talk about because you really get to start joining those bones together and start talking about movement, which is huge and also has some important clinical correlations as well. So this video, we're really just going to focus on some of the basics. We're going to get our bearings in terms of what even is a joint. What are the functions of joints? It's more than just movement. In fact, sometimes it's no movement. We're going to talk about the difference between structural and functional classifications. And then we're going to end with a discussion of what a ligament is. Ligaments are hugely important in terms of joints, so we certainly want to spend some time there. All right, so let's start with that first step with what even is a joint. And really, it's just a point of contact. A lot of times you'll hear me use the term articulation or articulating bones. The articulating bones are the two bones that are being joined together in order to form a joint. So usually it's bone and bone. Sometimes it's a little bit different when you think about a tooth and bone. That is an example of a joint as well. But for the most part, it's going to be where two bones are going to have a point of contact. Now, this third bullet point is an important one, and I want to make sure we get this before we move on. And it's that bones should not actually touch one another, okay? So where, say, your femur and your hip bone join together, you don't want the bones actually rubbing up against one another. That's actually a bad thing. You're always going to have connective tissue between the surfaces of bone. So actual bone-on-bone contact is bad. That's painful. We'll talk about some of the clinical correlations of where that can actually occur. But generally, in healthy individuals, there's going to always be connective tissue. Now, what type of connective tissue will differ depending on the joints, but there will always be connective tissue between the surfaces of bone. Okay? So again, you'll hear me say here articulation or articulating quite a bit. Just think joints when you hear me say that. Okay, so let's think about the functions of joints, and that's a little bit easier or a little bit more intuitive than, say, what we had with the skeletal system. And this first one is generally what we think about when we think of joints. It usually, when we think about joints, we think about it allowing movement, okay? But in some joints, actually, it will limit, or sometimes there'll be no movement whatsoever. If you think about where the bones of the skull connect to one another, those are joints, and there's no movement there. So that's actually an example of a joint with no movement. But a lot of times when we think of joints, we think about those, say, associated with your appendages or your limbs. That's generally what we think about when we think of joints, but it's actually a fairly large complex. Another important thing to think about when we think about joints is that certain joints are going to facilitate growth. And we talked a lot about this when we were talking about the skeletal system. So when we think, say, between the epiphysis and the diaphysis of a bone, remember, in individuals whose bones were still growing in length, you would have that epiphyseal plate within the metaphysis region. And this is actually an example of a joint. This is a cartilaginous joint here, because remember, there's hyaline cartilage there that will grow and then be replaced by bone. So oftentimes we think of this in association with the skeletal system, but these are actually examples of joints as well. Eventually, this will be completely replaced by bone, and we'll have what's referred to as a bony joint, and we'll talk about that in an upcoming video. All right, so let's talk everyone's favorite joint classification schemes. And I want to start off by saying that this is some controversial stuff. Depending on the discipline you are in, say you're a kinesiologist or you're an orthopedic surgeon or you're an anatomist, generally you hear very different schemes based on that. And generally they're pretty passionate, including myself, regarding which one is correct. So I'm going to keep it real simple. There are going to be two major types of classification schemes. The first one is the structural classifications. And so what this means is what tissues are actually connecting the bone. Is it cartilage? Is it more fibrous tissue? Is there a space in between? And this is really where we are going to spend the majority of our time here. The other major type is what's referred to as a functional classification. And what I mean by that is these types of classifications focus more on the degree of movement that's permitted at a joint. So is there no movement? Is there a little bit of movement? Is it what's referred to as a freely movable joint? That's what we're talking about there. So if you hear the terms synarthrosis, amphiarthrosis, diarthrosis, that's going along with that more functional classification. Again, we're going to focus more on this structural classification, but you may hear these as well. And I did want to point out this one term here, the diarthrosis, because this is the type of functional classification meaning a freely movable joint, but you very often hear this used interchangeably with synovial joints because that is which synovial joint is a type of structural classification. We're going to spend a lot of time going through this in upcoming videos. But I did want to mention that sometimes you hear these two terms, synovial and diarthrosis, be used interchangeably, because synovial joints are the only freely movable joints of the body. Now, one thing before we move on here and before we move entirely away from these functional classifications is that there is a general rule that the more mobile a joint is, the less stable it is. So if a joint doesn't move at all, it's incredibly stable. If, say, the joint moves a lot, say like what I have with my shoulder joint, the shoulder joint's comparatively much less stable than the sutures associated with the skull. And when you think about that, when there's less stability, there's more likelihood of injury or damage to those structures there. So those less stable joints are generally the more clinically relevant ones. Okay, so let's go to those structural classifications. And we're going to talk about the fibrous, cartilaginous, and synovial in more detail. But I did want to start off with the two basic types first. There are going to be joints where the bones are joined by a solid mass of connective tissue. So these two examples are fibrous and cartilaginous joints, which you see here, here as well as here. And so what I mean by that is, say when we're talking about a suture, here's a bone, and then in between you have this solid mass, in this case of fibrous tissue. Now, when we're talking about a cartilaginous joint, here's a bone, and then this solid mass of cartilage connecting the two bones. Okay, so that's one type of structural classification. Then you have the other type where you have a bone and you have a bone, and these two bones are going to be joined by a connective tissue capsule. It kind of envelops the bone on either side, and you're left with space in between the bones. Okay, so what that's referred to as a articular cavity. It's going to be lubricated by synovial fluid. And these are important. This space in between the bone is important because it allows for more movement to occur at these joints. And so the major example, and really the only example of these, are going to be synovial joints. And again, we're going to talk a little bit about fibrous and cartilaginous joints, but the majority of our time, we're going to be focused in on the synovial joints. All right, last thing I want to talk about in this video are ligaments. And I want to talk about them because I love them. They are awesome. All joints have them. It literally means to bind. So these are going to be the components that are binding the bones or joining the bones. And what's unique about ligaments are that they are going to go from bone to bone. Okay? They're not tendons. Tendons go from bone to muscle. Ligaments are bone to bone. And these ligaments are going to be composed of dense regular or irregular connective tissue, dependent on the specific ligament. And there's lots of different classification schemes for ligaments. That comes up a lot. Classification schemes, everybody loves them. Everybody has their own. But really what we're going to use are that there are intrinsic ligaments and extrinsic ligaments. Intrinsic ligaments generally how we're going to use them for this course are the ligaments in which you're actually binding the bone. So in this example here of this fibrous type of joint, you had the bone, and then you have this intrinsic ligament called the sutural ligament, which is actually connecting the two bones or joining them together. So that's how we are going to use the term intrinsic ligaments. The other type are the extrinsic ligaments, and these are going to be supporting bands, okay? So they can either be located within the joint capsule, so within the joint, or outside of the joint that are adding to kind of play a role in checking movements that can occur at the joint or just providing further protection of the joint. So a lot of the ligaments that you hear of, say if you've ever heard of your ACL or your anterior cruciate ligament, this is an example of an extrinsic ligament. It's not what's actually kind of joining the bones together, but it is going to have a connection between bones in that joint. That would be the ACL is actually an example of an intracapsular because it's actually within the joint cavity. So those are going to be the two major types of ligaments. We're going to talk about some of the more clinically relevant or functionally relevant ones as we talk about each individual joint as we keep going. So this is a key point, something I want to make sure that we feel comfortable with before we move on to another session, is ligaments are going to connect what to what. All right, so pause the video if you need to think about it. Hopefully you just immediately are going with A being the correct answer. So this is going to connect bone to bone. Say bone between teeth, that's another example too. But really, for the most part, you're pretty easy to go with bone to bone. Bone to muscle is something that we're going to talk a lot more about when we get to the muscular system. This is going to be a tendon. All right, gotta love a tendon too. A tendon can protect a joint as well, but it is going to go from a muscle belly to the bone. Not bone to organ either. Bones can certainly have a very close relationship to organs and is an organ itself, but that's not the answer that we were going for. A is going to be the correct answer. Ligaments connect or going to go between bone to bone. All right. Most excellent. So that was a fun start to joints. Now let's talk a little bit more about those structural classifications. So we'll talk a little bit more about fibrous, cartilaginous, and synovial joints. Thanks for your time and attention. And if you have any questions, please reach out.